sir.
Yeah.
Good evening, sir.
Yes.
My project title is Smart Wafer Defect Detection using lightweight CNN and classical filtering. This project primarily focused on developing an efficient AI-based framework for semiconductor wafer defect detection. So let's move to the introduction.
I can't see the slide. Go to the slide.
सर स्लाइड नहीं दिख रहा है क्या?
हाँ, स्लाइड नहीं दिख रहा है, आप स्लाइड में जाओ।
सर मैं स्लाइड में ही थी।
वो शेयरिंग मोड में है ना?
यस सर।
Yeah.
So good evening, sir. My project title is Smart Wafer Defect Detection using lightweight CNN and classical filtering. My name is Lokhimi and I'm doing my BCA honors in artificial intelligence. My project is primarily focusing on developing an efficient AI-based framework for semiconductor wafer defect segmentation. So let's move to introduction. Semiconductor wafer are important in chips manufacturing, so defects in wafer can affect a lot of the product quality. And also manual inspection, like traditional inspection methods, are very time consuming and can be less efficient. Also, the AI inspection based method help automate the inspection process and improve accuracy. So the main problem statement can be divided into 4 sections. That is existing deep learning models that provide good accuracy, but many of them actually require high computational resources. So a real-time defect detection is still challenging in resource-limited system. So the main goal was actually to design a lightweight framework that can maintain a good segmentation accuracy while reducing a computational cost. And my project objective is that the main thing is to develop a lightweight framework and also to achieve accuracy and in defect segmentation. And one of the main areas is to reduce the inference time because it's primarily focused on a lightweight part of the in IT section, and to make the system more suitable for CPU-based implementation. This will be my proposed framework. So when a wafer image input is taken from a public available dataset, that is WM811K, and it goes through a preprocessing that is used as Gaussian filtering or noise reduction. So it can be later sent to the encoder, which is our model, a lightweight model that is MobileNet V2, which I have currently used. And then it go through a unit decoder that reconstruct the segmentation mask, and it's considered a viable method for now because it identified the defect region in the wafer image. And finally, the output section, it compare it with the binary mask and show what is detected defect in the region. And here is my data set and preprocessing details. It is a public wafer defect dataset, as I have said, and it contains around different type of patterns. It categorized into 9 categories. So I have used 2000 samples from the dataset for training and specific 400 for testing the model. The preprocessing pipeline is also available here, as I have set to load and resize it into 128x into 128 pixels so that it can be so that the dimension can be properly adjusted in the model. And then to normalize the pixel value scale into 0 to 1. And the preprocessing step goes through a Gaussian filtering, which I have choose the 5x5 kernel, and it specifically choose to reduce the noise and also to improve the defect visibility. And after that, it's the mask generation. which the defect pixel is showed as 1 and the background will be detected as 0. And here will be the model architecture.
The PPT again
As I have mentioned in the
disappears.
Okay, sir. Sir, I guess it's kind of I'm doing nothing, sir, but like
I don't know, but it was showing, just it disappeared. You go to that slide mode again,
I'll just click on, yes,
or
sir,
you
I'll
can
just
come to
click
the
my
this
share screen again.
demo part.
Dem
See, tomorrow in the presentation, most important part is the demo. All will be looking after what you have done. So output should be showing. Yes, it is showing now.
Sir is okay. Sir. Oh,
And the slide, I have to say, this is a very proper way of organizing the slides. I can see here from the Lokhimi slide, and I can suggest that all the members should focus on the way she organize, and you can also organize so that the contrast will be like that, that every text is visible, right?
yes. So I was in my current model architecture slide. Here, which I have explained already, the in the proposed framework, it uses
So
a mobile net V2
again,
encoder.
click to exit. Full screen is showing. You can do one thing, Lokhimi. Have you displaying it that particular? Oh, you just now for a moment switch off the camera and then go to the slide or the demo architecture. Maybe
Okay,
because
sir.
of the network or whatever, this problem is happening. You directly, yeah.
Sir, is it visible?
Yes, it is visible. Now, yeah. Briefly describe this and go to the demo part.
Okay, sir. So my model architecture include mobile net V2 encoder and a unit style decoder. And also I have used dice loss for to improve the segmentation accuracy and also to measure the overlap between predicted and actual mass. This will be my training and evaluation setup, which I have used during my implementation. And this is the result which came through, in which I have said that the dissimilarity coefficient across the test set is here in the chart, which to summarize the performance, the mean similarity coefficient is showing 91.76%, and the standard deviation, which is a pretty good number for a training set, and the inference time is also as the target was achieved, as it was 44 milliseconds. And this is my implementation and output for each wafer map. This is the section of filter input after the Gaussian, and then the ground truth mass, which is then go through a predicted mass, and this will be the overlay. This is the best and worst case analysis, which the best case showed a 0.9184 DSC, which shows with a worst case analysis as well, that is 0.8984. And
Okay.
for the comparative
Yeah, Lokhimi, do you have the model ready to show?
No, sir, I just took screenshot of the result and output and paste it in
But
my
tomorrow when you go
slides.
for the presentation, keep the model ready.
Yes.
Okay. So whoever
Sir, do I
listening
have
now,
to
you have to
the
yes, tell me.
sir,
Now switch
do
on
I
your
have to
video
show
mode,
the
Lokhimi.
actual?
Switch on your video
Okay,
mode.
sir.
Yeah. Because anyway, the slide is not visible, so that's why I'm asking you. So you tell me 1 and 2 lines that
Yes, sir.
what novel thing you have done in this project.
Sir, I have combined both like a lightweight model with traditional used to detect such segmentation tasks, which my project is primarily focusing on wafer maps so that it can detect the defects in modern manufacturing industries. And yes, it's primarily focusing on to reduce more hardware constrained environment so that it can be usable for more low cost
Productive
hardware.
nodes. Yeah, I got it. And you have used some metrics like dice, right? DIC, dice.
Yeah, yes,
Yeah,
sir.
yeah. So can you just tell me at one line for this that why we use this dice?
Sir, it measured the segmentation. Uh, Usually when we do a segmentation task, it shows a localization of overlap between the predicted mass. So dice loss, we use it to measure the accuracy of which pixel or localization specific can be measured properly for segmentation purpose.
And we have used TensorFlow and Keras, right?
Yes, sir.
What is the purpose of them?
Sir, I have used TensorFlow and Keras to like train the
Model.
existing model. Yes, like MobileNet V2. And also so specifically train and adjust with what I am specifically focusing on.
Okay, good. Very good. And I hope that this project can be extended if things are possible here. And yeah, now what I can say, overall the presentation, I'm very much happy with your presentation, Lokhimi. And problem statement you have mentioned clearly, objective you have mentioned clearly, and practical part also being demonstrated by you very well. So overall satisfactory performance by you. But one thing remember, tomorrow, please keep the model ready with you. Okay. And show them. And we don't need to talk a lot. We just need to focus on the brief things. What was the aim? What was the problem statement? What was the gap that we have found from the review? Okay. And how we deal with that. And what were the objectives that we have fixed for this 1 year and how much we have accomplished. Right. This is the things that you have to focus on. Overall, very good. And 2 things you do. GitHub account, I already informed, right? About the
Yes.
GitHub and this, or sorry, I think it is clear to you, right? This thing you need to do,
Yes,
but
sir.
not for tomorrow, but this is for a record for our next means whatever our target. They can see that what work we have done during our graduation, right? So Lokhimi, that's
Thank you,
it.
sir. Yes.
Best of luck.
Thank you, sir.
Okay. Now coming to the next group.